Robert.
Hi, Edward. How are you doing?
How are you? Are you well?
I'm doing very well. Having a little bit of trouble with one of our conference rooms here currently, so I apologize if the audio isn't the greatest right now.
No, it's perfect. It's perfect. Well, first of all, thank you very much for taking the time to do this. I appreciate that. The RPA is, both a fascinating place to be at the moment, but also hectic. I understand you've been in hospital as well, so that's nothing sort of works together. So really, the way these sessions work is that we invite an expert along, like Robert, to kind of talk through a specific issue. We do it live, but obviously the recording's available for everyone to see thereafter. If there's any questions along the way, please feel free to ask. But with that, really, Robert, I'll pass over to you rather than me showing how little I know. I'll pass over to the expert.
Okay, great. Thanks, Edward. I want to say that I do have my colleague, Isel Tula, and I were both here on the phone. She's the RPA lead as well on the case study that we will be going over later in this presentation. So, Isel, if you want to introduce yourself.
Hi, how are you?
So we're going to be going over just a brief introduction first of Automate Work. We're a digital process automation consulting firm, and RPA right now is one of our main focuses for a lot of our automation opportunities. RPA is definitely it's a big buzzword right now in quite a lot of industries. So we are going to have a little bit of a brief introduction as to what RPA is. If you already know what RPA is, I apologize. I'm just going to be going over this rather quickly. So it's a technology that allows configuration of a computer software, that's where the term robot comes in. So it's a software bot to capture and interpret existing applications for many things: processing transactions, manipulating data, triggering certain responses, and communicating with other digital systems, taking over a lot of what the traditional swivel seat approach that human processes would currently be doing. There's an alternative, to the traditional IT approach, developing a whole new system or coding integration layer, in order to automate a business process. Obviously, that takes much more time, and the initial outlay costs are much higher. So we're just going to move on from here. That's a brief RPA introduction. We're just going to be jumping right in after that as to what surface automation is. But prior to that, we're going to be going over some of the leading RPA and cognitive platforms. So if you want to skip over it, brief little introduction.
Sure. So basically the ones that we have been hearing a lot lately, the customary Blue Prism, Automation Anywhere, Redwood, Pegasystem has been there for a while too. But the newer ones that we have been seeing for the last couple of years, that they have increased the level of information that's been out there, UiPath, WorkFusion. We have worked with most of this, and we have seen that they are very similar. They have a lot of similarities. The only things that we're going through is that depending on, client requirements and all that, and depending on that, we choose a tool on it. The AI platform that is very, you could say, in right now, Microsoft AI, we have seen IBM Watson. Most of these tools have a direct link to this AI platform. If they don't have, the platform has sufficient information to do a link of the RPA platforms and the AI platforms. This provides the bot to be a more intelligent bot and have a deeper analysis on the automations that you're developing.
Exactly. So it allows an integration that RPA can integrate with some of these AI platforms to handle some more complex logic that would be much easier for a platform like Watson, for example, to handle than trying to build something ourselves or using any type of functionality within the RPA platform. So it is robust in that sense that it's able to integrate with a lot of third-party platforms. Not to mention a lot of OCR engines as well. So now we're just going to be moving over into this next slide that's going to be based on surface automation. That's the main point of this presentation. RPA Citrix, the whole article was pretty much just about surface automation, the challenges that lie within surface automation, and that's something that we're going to be going over now. So what is surface automation? So it typically refers to visual automation, where you're required to use images, screenshots, or optical character recognition, or OCR engines, in order to automate an application. I put a definition may vary there, because you'll see that certain people have their own interpretation of what it means, but the overall idea is that we're using images rather than object properties. You know, that's what we're interfacing with. So to really go, before going into that, we really have to explain what's the difference between a thin and a thick client application. Again, so I don't know if this may seem rather rudimentary to some of the people on the call, but I do think it's rather important for us to go over that prior to going into overall surface automation, just because it'll give a better picture as to why we have to do these things. So first, I'm going to go over a thick client. So a thick client is housed primarily on a local machine. Now, it essentially will provide users of it with a lot more features, graphics, and choices, so to speak. So it makes applications much more customizable. And unlike thin clients, thick clients do not rely primarily on a central processing server, because the processing is done locally on the user system, and the server is accessed primarily for storage purposes. So for that reason, thick clients traditionally are not well suited for public environments or for large-scale integration, just because of the overall processing requirements for them. So to maintain a thick client, IT needs to maintain all systems for software development and upgrades, rather than just maintaining the applications on the server itself. So they require much more specific applications, and it poses more work and limitations for overall deployment. But the trade-off of that is that it's more robust and it's on a local computing environment. So that's more the features and the pros and the cons of a thick client application. And just an additional, I guess this would be considered a con, is that this applications do traditionally take up much more memory. And of course, they run completely on the individual computer's resources. So that means the security of that application is dependent upon the local computer system. And an example of this, which everybody uses, is Outlook. Outlook's a perfect example of a thick client. Or some trading portals as well, stuff like that. Everybody pretty much has probably used a thick client at some point in their life. And Estelle's going to explain what a thin client is, and we'll be going on from there overall into surface automation after.
Yeah, so basically, a thin client is used to describe an application that does not run on the local machine, contrary to the thick client. So in the thin client case, the application of the software is run on a server, or on the client server, whatever they want to host it. And the client where we're going to run the robot will just access an image of it. In a thin client, we're looking at applications that operate on a remote machine and are presented to the user via virtualization software. Like, for example, Citrix is a very common thin client. At times, thin might be defined as simply not needing, the software or operating system installed on the user machine. So what they normally do is they have a centralized server with several applications or even several websites. What they do is they replicate this server to a different clients or users. So they just need to go to that Citrix environment and access an amount of different websites or different software, instead of just installing them separately on every local machine. So any update that has been done to a thin client it just needs to be done in the main server, and it will replicate to the local machines. That is why the thin client is most used, but it's very difficult to automate, because you're never going to be sure when is the update going to be coming in. When you open the access, things might be changed that you didn't have any account into it. So yeah, for example, we said Citrix, or basically any virtualization system that we can use on it.
Yeah, ironically, a thin client is best suited for humans, but not so much for bots. But there is a way around this, and that's the point of this overall surface automation. And the way that you do so is by something called computer vision. And computer vision, there's many definitions to it, but essentially it deals with how computers can be made for gaining a high-level understanding from digital images or videos or whatnot. And if you see there, I put a bottom-up approach because that is the approach that's being used currently in the computer vision space. So it applies a series of transformations to an image and discovers, edges and the object, the perspective of movement when presented with multiple pictures and so on. So essentially, you're giving it more and more data for it to recognize a particular image. And there's much more into that, but I think that's more than enough for us to understand at least how computer vision works with surface automation. Surface automation is required to use images, screenshots, or OCR. Computer vision is essential in order for surface automation to actually work. So now UiPath is for at least 2017, according to Forrester Researcher, their computer vision technology is considered the best in the industry currently. So it is really dependent upon the overall process, what you're doing, what are the requirements of that process. And for this one case that we're going to be going into a little bit later, UiPath was deemed the best tool for that particular project, and based a lot mainly on their computer vision technology and capabilities. So if you see on the right there's you'll actually see that's the UiPath platform. And on the right, you'll see that is just an example of a particular application that is virtualized. So we would be applying surface automation techniques on there. And for this particular example, if you'll see on the right, it says transaction number, and then it'll have a number 802245. So what you would be doing in surface automation, we'll be going a little bit more in depth to this in the case study, but briefly to go over it, is that you would be searching an image of this application for transaction number because it is a unique image on this application. There is no other fields that have that transaction number title, and then you would be basically mapping that to the number to the right of it, which is where the actual transaction number would be held. And one of the activities in which you do that in UiPath, if you see there, it's a little bit hard, it's highlighted, it's called get text. And that's where it's actually just getting all of the text of a virtualized application, and you're able to apply different methods in order for you to map accordingly. So that is a high-level overview of surface automation. We're going to be going into some of the challenges, additional challenges, the methods in which you are able to solve some of the challenges rather with them using the UiPath platform.
So basically, when you're handling a visualized environment, the first thing that you're not going to be counting on is the object properties. We rely on that when we do a lot of automation processes, but when you're using virtualized system, you don't have that to work with. And then the other thing is that the anchors might change. That's one thing that we rely on a lot, and that's something that you are not going to have in a virtualized environment because they're going to change, especially if the resolution of the screen change, the anchor's location is going to change. Maybe when you click it, the screen is going to change the color, and that is definitely going to make the whole process to change according to that. Now, with this example that we use UiPath, there are just several methods that we can use to try to go over these challenges. One is the click image. So for the click image action, you can use it to click on mostly anything. So any image that you might want to click in your automation. For the click image, like Robert says, we're using I think they're using the bottom up approach for the computer visualization. The thing with click images, you have to make sure that image is not going to change, or that it changes and you're still taking that into account. For the click text, they use OCR to scan the screen and find that text in your whole image. So this enables you to extract a specific piece of text and click on it accordingly. The select and copy is another very important activity. So it's the easiest output method being used in Citrix automation, but it works only for selectable text, like text boxes, yeah. For example, yeah. The scrape relative, So this allows you to scrape just a portion of an image. But for the scrape relative, you need to use an anchor for that, and a reliable anchor. For the while loops are very important when you use visualized method, because sometimes it takes time for a page to load or a Citrix environment to load. So you use the while loops to keep looping through that screen until you can actually see the image. If with the while loop you're gonna find it, then you're probably not going to find it anytime. So for the image exists, we use that with the while loop sometimes to wait until that image exists to proceed with your process automation. With this activity, you normally get a Boolean variable, so you use that with your process, yeah.
Using that Boolean output from the image exists in your while loop. So basically, you're saying until this image is found, you're just going to keep waiting because you're under the assumption that it's loading. Yeah. And we'll go into the use case of some of the dangers of that, but it is unfortunately a requirement in most cases when dealing with surface automation. And I'm going to also address something as well on the challenges side. When it's saying the absence of object properties and why that's so important, in a more layman's terms. So the object properties is really what in any type of fit client, for example, or if you're automating a website, you're able to link to object properties or HTML properties, whereas in surface automation you're only really linking to an image or a screenshot. And the problem with that is that object properties are much more stable, of course. And it's a lot easier for you to put in certain logic, such as wait times or waiting for an object to exist, rather than waiting for an image to exist, because the image itself is up for interpretation depending upon the output, so to speak, of the computer vision. So that, as far as challenges, as to why it's such a big challenge when there's no object properties to link to, is that it's not as stable, of course. And to go into the methods as well, all of these methods, aside from maybe, I guess, the while loops, of course, are all really UiPath specific. So the click text, the select and copy, the scrape relative, the image exists, the click image, those are all activities or, ergo methods in UiPath that can be used to overcome these surface automation challenges. So, if you're not rather familiar with UiPath, a lot of that may just look, may have no relevance to you. But if you ever use UiPath, you will see those particular activities that can be used to go over these surface automation challenges. And on the right side, just because we're on the methods section, that is what the properties panel would look like for majority of these click image activities. And if you see there on the input section, they have an accuracy parameter, and that is set from 0 to 1. So this is in the tips. One of the main tips that you want here is to make sure that your accuracy score is adjusted relative to the overall quality of the image. So, for example, if you're going to be using, let's say, a logo as an anchor before inputting into a particular input field, that there will be a design logo right above that you can use for an anchor. Now, as Estelle was saying, that with these Citrix or these virtualized applications, I won't just say Citrix, but with these virtualized applications, the load times vary, depends upon a lot of factors that deal with the overall infrastructure of the network. So sometimes the loading of that logo, it may change, or it may not be, the resolution may change, which is something that we actually encountered in the case study. And it was not something that was so apparent that we were able to automatically say, oh, the resolution changed, because it was very minute, but it was enough because of the image itself. It was enough to throw off the automation. So adjusting this accuracy score, it's based from a scale of 0 to 1. The higher up you get to 1, the higher it needs to match that underlying image. So usually we try and set it at around a 0.8, where it gives it enough of a bandwidth, I guess, so to speak, of being able to adjust for if a resolution is changed, but not to a very large amount that'll affect the input of or the extraction of the necessary information. That's just something to take into account, is to make sure you adjust that accuracy score accordingly. And going into that, another one of these tips that we use here is unique image inputs. And if you see there under that accuracy, there's an image parameter that you're actually able to upload an image into there that you can use to base off of this exist activity. And the reason why it has to be unique is because, let's going back to that logo example, say that there's multiple logos on the same screen. It needs to be able to understand where, if you're using it for an anchor, that is, where that the specified logo is that is next to the input box that we're going to be interacting with. So making sure if you are basing it, if you are using an image parameter, you have to make sure that it's a unique one, because if not, it can definitely throw off the overall automation and when finding the location in which you need to interact with. And an example of that, why an image might change, and this is something, again, that in the case study that we ended up finding out, or discovering rather, is that if a link was clicked once, it might have a surrounding border where the color will change. And when you click on it again, that would disappear. So you need to make sure to take into account when, in this particular example, that is, that when you click it, the image of that line item will change due to it being highlighted. And that is a completely separate image than to when it's not highlighted. So if you're using an image exists off of a highlighted image and it's not highlighted, it won't be able to find it unless you either adjust the accuracy score so low to where it's just looking for a particular subset in that original image, which we wouldn't recommend. Instead, you would want to use unique image inputs of both the line item being highlighted and the line item not being highlighted, and making sure to kind of take that into account. That the main point of saying that is that you need to take into account when dealing with accuracy that you might need a different accuracy for the same image, and you would need it to be higher in certain cases, because you want to make sure that you're having when interacting with something, you're having a high enough confidence interval before you input or extract anything. So as far as overall tips in respect to the challenges faced, making sure you're using suitable anchors, and those anchors are based on unique image inputs, and that the accuracy score, is high enough to where you're making sure that you're interacting with the correct location is paramount in order for you to really have a successful surface automation. And the methods in which you would do so is through either clicking an image or clicking a certain text, or waiting for an image to exist and using those outputs into standard programming logic like while loops or do whiles, to ensure that before moving forward you have all the necessary information and you're waiting for the appropriate load times.
Yeah, because one thing that we never recommend is to use a delay to wait for an image to appear, because with the delay, one time it can take 2 seconds, sometimes it can take 20. So that's why we rely a lot on while loops and any other type of.
Right. Yeah. And delays are a little bit of a lazy approach, just because it's fixed. Like it's outside, it could be 20 seconds, it could be 5 seconds. But the problem is, if it only takes 1 second to load, and you have a 5-second delay, you're now waiting 4 seconds for nothing. So using those while loops with some type of activity that has a Boolean output is really important when dealing with surface automation. So now that we've gone over for some of these challenges that you'll face, when doing any type of surface automation, the methods in respect to UiPath, but can be applied to other platforms, and the tips in which you use those methods. We're going to be going to the case study next. Now, Estelle will be able to explain overall some of the objectives of that. She was the genius behind the majority of this automation. But this particular case study essentially is job monitoring. Now, on the right, that is not obviously the application in which you interface with. That's just an application that is somewhat similar to what we encountered. Obviously, for privacy reasons, we're not able to provide neither the application or the client themselves. But the overall objective is what I'm going to explain first, and Estelle will go a little bit deeper into some of the problems that she faced and the solution, obviously, in which to get over those problems. So the overall objective from a high-level point of view is that it's monitoring a log, which is in a spreadsheet. And this particular spreadsheet has over 100 different jobs. Keep in mind that the amount of jobs can vary. Jobs can be added or taken away. And you have to monitor for those, each individual job, you have to monitor specific start and stop times and the job details that all will be found in the virtualized application. And then once extracting that information, you have to update that same spreadsheet, with the pertinent info that it can be handed off to the engineer on duty. And if, of course, standard exception handling, if there's certain validations in the job details, the start and stop times, that if a job wasn't started by a specific time or didn't end by a specific time or had any keywords in the details, we would notify the engineers accordingly, but make sure not to stop the overall automation. As what was most important is being able to handle these exceptions, case handling, and then being able to make sure to continue with the overall automation. So that was the overall objective of this particular case study, and it sounds rather simplistic, but when you dive into the details of service automation, you'll find that it's anything but. And so I'll go a little bit into some of the problems that not just with this case study we encountered, but you would also encounter with any type of service automation that you'll be doing that deals with this type of application.
Yeah, so one of the first things that we noticed about the process that we needed to develop is that the system, like the worksheet or the spreadsheet that they use to monitor this job, is the naming convention is not even the same one as you can find in the system, right? So we needed to find some middle ground to connect the system and the spreadsheet. So for that, we created what we call the master sheet to log the information from one place to the other and find a common ground in it. That was the easy part. So after that, one of the big problems that being this one in this case, this one was a Citrix environment. So one thing was that to be able to log in to the system, you needed to have a physical token. So this cannot be in an attended bot. It needed to be an attended bot. Someone needed to be there for the bot when there was a problem with the logging. And besides that, the internet speed varied so much with the Citrix environment that sometimes you open the website and it was loaded super fast. The second time it was waiting forever. The inconsistent anchor tag. One thing that we found, and we explained it before, was that the image that we might want to use as an anchor tag changes so much. When you click it, the background changes to yellow. Sometimes it moves a little bit to the right, and we had issues with the resolution too. Since it was in a Citrix environment, the master server was where that website was hosted. It changes every night. Every night they update it. Over the weekend they do a general update. So in this case, it was open in the Mozilla browser, but every time that you open it, it changed. It restart all your options, your internet options. So it blocks any pop-up. It throw pop-ups just because of it. And every time it was different. So the job status also, the validation criteria for the start and stop jobs, that changes. With every new job that they added, it might change. So you have to take that into account. And like we said, the Citrix auto updates every week or sometimes every day, something new might pop up. And one thing that it was very important in this process was that the system shut down in the middle of the night. And one thing that we need to explain about this process is a nightly process. So it was not a daily process. So it would run every night during the whole. Most
job monitoring process like this.
Yeah, it's really in the night.
It's at nighttime. So it would run from midnight to 8 a.m. and all jobs would have their own specific start and stop time criteria based upon what the overall customer or i.e. job specifies. So job 3 needs to be started at 12:05 a.m. but has to end before 12:20, whereas job 7 has to start by 12:30, but it has to end by 6 a.m. So the mapping of this criteria into what this all said is the master sheet was very important. And one of the main challenges with that as well is that when you're searching job 3 in application, the details, or rather the job name, excuse me. So job 3 when searching in the application is not job 3. It would be the name that would be a variation of job 3. So say it's let's say McDonald's Corporation. Let's go with that. So it would be McDonald's Corporation in the job sheet, but in the application you would only be able to look up the job if you put in McDonald's. And obviously there's much more details that go into that, but the main point is that you have to create some type of map, and that wasn't initially apparent to us, because some jobs would have a direct match. So like Burger King would show up as Burger King, but that initial mapping really was the foundation of how we were able to overcome a lot of this validation criteria for the start and stop times, as well as the job details. But that's not taking into account, which we'll be getting into next, was the actual extraction and input of this data into the application.
Yeah, and one thing is with when you're doing job monitoring is that, like you said, some jobs were supposed to be starting by 12 a.m. So you have to take that into account when you're doing the monitoring, because maybe for monitoring those 100 jobs, because it's a continuous monitoring, it might take an hour to the first 100. So you have to take into account that one of those or 5 of those 100 needs to be checked first to make sure that by 12 a.m. they started, or by 12:30 they must be completed. So there's things that need to be taken into account when you're doing a job monitoring of that scale. And one thing is that you might have an issue in the middle of the process with one job that it might stop your process. But you have to take into account that you cannot make the bot stop there, because then you'll be losing a lot of time for your client monitoring jobs. So when that's the case, you actually need to find an alternative that if the job stops, keep moving forward, and then you can check that out later. So there's a lot of exception handling that you have to do when you're working with a visualization system. So one of the things, we can move to the solutions because there are some problems, right? But we want to know the solution. So one thing that we handled for the first problem that we have, the virtualized applications with the different load times. So like we said before, we use the while loops, and we use a lot of image access. Sometimes you need to change the accuracy to get like a better output, because like Robert said before, you might have a logo that is repeated. Even if the size change, it will still detect it if the accuracy is super low. So you have to do a test when you're doing an accuracy level to see what is returning from it. So we use every step of the way, we use the image access, in this case with the while loops, to make sure that that was there before moving forward. And one thing that you have to do when you start doing a process like this, you have to look at it from the outside. You have to think, if something breaks, what do I need to do next? So you don't want to do a very complex process that is built into one package, because if something small in that process breaks, the whole package is going to break. So sometimes you don't want that. If some small part breaks, you may be able to continue on the next part. If not, then you will need to notify something. So that's one of the things that we did on the process. So we did extensive use of anchors. The only good thing with the process was that the logos and the anchors were very specific. So there was no repeated data. So we were able to rely a little bit on that, especially for the data inputs. We needed, like Robert said before, we needed to input the job description and get the details of that job. The initial job validation of the spreadsheet, based upon updates data through the process cycle time, that's something that we did. We created, like you said, a master sheet that it will log all that information. But we have to take also into account that once a job was completed, there was no point in going over that again and again.
Right.
So one thing that we try to work on is once a job is completed, there's no need to go back to it. Let's keep monitoring the other jobs. That way, by 3, 4 a.m., most of the jobs were already completed. So if there was any issue, it would be really fast to notify the person that was going to handle any escalation issue.
Yeah, and that as well is something that's really important, that whenever you're doing any type of job monitoring itself, you always have an initial list. And you want to make sure that you set up your automation in a way, like Estelle said, to where you're not, because especially you're doing it in a virtualized application, and loading is such an important part of it. You don't want to be running any unnecessary cases. You want to make sure you're only running ones that have a requirement to do so. So setting up that master sheet, that initial job validation is very important. But actually going back now just to the multiple anchor tags, one thing that was a very big problem here that we actually did not include in here was that the extraction of the start time, stop time, and the job details, they came in a particular table. Now in this table, there wasn't a single line item that was specific to that particular job. As we said, job 3 may pull up as job 7, or rather McDonald's Corp may only pull up as McDonald's in this application. So you may have multiple results. And when doing surface automation, we rely a lot on, when possible, is keystrokes or hotkeys. So in this particular instance, is actually we discovered that when you take that particular table and there was a print function. When you hit print and got to print preview, it gave it in a very formalized table that is much easier for us to extract and to parse. So looking for that like hidden functionality, well, not necessarily hidden, but functionality that's specific to the application, it may not just jump out at you right when you see it. You have to make sure that you're looking at all of the best ways for you to be able to get the data in which you need to interact with. Because if you just try to right-click, select all, copy, and then put it to a spreadsheet, it's going to be much harder for you to parse that data or be able to work with it than a built-in functionality to this application that has a print preview function, which gives it in a table format. So that was something that we did. I apologize, did not include in this problem, but I do remember now that was not necessarily a saving grace, but it definitely saved us a very big headache when we did pull this information. Is that we were able to parse through it a lot easier because we found that hidden functionality in the application. So relying on hotkeys, or rather using hotkeys to your benefit, is very important when approaching any type of surface automation. But also looking for that hidden functionality in these particular applications is also just as important. Because you don't want to be doing, especially when dealing with this, you want to be putting as little amount of interaction as possible with the actual application, just because it allows for allows it to be a lot more stable.
Yeah, and when you're dealing with a process that you like a virtualized environment that you don't know how the system is going to respond, you always take a little bit of time to do tests, because maybe the client has a way to proceed in that case, but you might find an easier way to approach that same problem. So that's always recommended. Try to do some testing on that environment before you actually start developing. And like we said before, one thing that it was a big issue was that the system restarted at, I think it was 2 a.m.
2 a.m.
Yeah. So for that, we actually had the bot notify someone when that system went down, and then keep looping every once in a while. This is another use that we use, that while loop, to wait until someone restart that system, because the bot was not able to access any the physical token to input into that system. So sometimes you have to find some alternative when you want to handle a problem like that. And like Robert said, in the case of the Excel, now we were able to map the results to the Excel. One thing that there was a problem is that there were similarities on the job. Sometimes you needed to map the exact name to actually get the output, because if you do something that is similar, you will get the wrong output, and in this case, that's a no-go.
It does not work.
Yeah.
So you know, in closing, for at least just on this case study as well, you know, I'm sure that probably somebody would be saying, you know, well, why didn't you just, you know, change as far as access to it, change it from a hard token to a soft token, or put it in a different environment. I think anybody that has at least from a developer standpoint, or from any type of project management standpoint, you know, you want to make sure you're putting as little amount of overhead on the client as possible. You want to make sure you're really, you know, RPA is really on the surface layer. So as little change as possible is going to go over a lot easier with the business. But if you're able to change the process just a little bit to your benefit, in this case, the print preview, obviously a human would not have to do that because they're able just to look and see the table to see those times. The bot is not able to do that. So the human didn't know, or the engineer did not know about that functionality simply because he didn't need to. So we are essentially changing the process in that way, but it is a very little, it's a low impact change. So you want to be careful when approaching these automations, saying, oh, well, we're going to change your process in this way, because like I said, anybody who's you know, been in an automation project knows that that's not it's a lot easier said than done. So if you're able to use any type of functionality that is specific to the application to your benefit, you know, definitely do so. And I would say that exploring that functionality prior to development would be very beneficial. So guys, this is as far as for, you know, the introduction. I know we're 12:41, so we're a little bit over on the timeline that we had here. I know next we want to make sure that if there's any questions, you know, we can answer them to the best of our abilities. Edward, I know that everybody is, I believe, muted, so do we just answer the questions via the chat?
Yeah, I mean, via the chat. I mean, first of all, thank you. That's very, very powerful what you've just been through. I mean, my first question was around, you know, the time scales. You know, from you know, starting this, you know, this example, this case study, and actually completing it to, you know, or whatever completion really means. How long did this take you?
So it was given on a 6-week overall end-to-end deliverable. So that the first week was, you know, just initial discovery, you know, determining what are the requirements for the start and stop times, the job details, how those are relative to the initial spreadsheet, and learning you know, the interactions of the application, learning, you know, when the application was to be shut down at 2 a.m. That was a IT requirement that they have for all their applications for maintenance. That was something that we weren't initially aware of, you know, when going into this process prior to discovery. So the first week was the initial discovery. It was slated for, I believe, 4 weeks of development, and then 1 week of UAT. And then we had another 30-day, you know, sort of a hand-holding period, if you will, of going live, to making sure that somebody, ergo an engineer, their seller, myself, the seller much more often than I did, was on call while running this, you know, from that 12 a.m. to 8 a.m. time frame after running in UAT and prod. So from initial discovery to deliverable and prod was 6 weeks. And then we had, again, another 30-day hand-holding period just for any additional exceptions that had to be added to it to make it just much more robust.
Okay, and in terms of other solutions, you know, beyond UiPath, did you look at other options?
Yeah, we like to say that we're platform agnostic, if you will. So we don't have a strict preference to one or the other, realistically. But for this particular project, just because it was much more of an initial automation, we did take into account the initial outlay costs of the different softwares, of course. UiPath being a much lower initial outlay cost, but the functionality when it comes to the computer vision was, like I said, you know, for last year was definitely, if not the industry leader, one of. So it was much easier for us to integrate UiPath for this particular process. But we did have other ones in mind, such as Blue Prism as well. But for this particular process, UiPath was deemed the best fit due to, you know, differing factors that not just dealing with technology, but more with initial outlay costs as well.
Perfect. And in terms of what's the three biggest things you would give anyone advice on, just to sort of summarize, everything you've been through in the last 40 minutes, what are the three biggest tips of advice you'd give?
Well, when done with surface automation, I'll definitely have a sell kit to her because she had a much rougher time as far as development. She put in much more time on this one than I did. But the main one, at least in my opinion, the number one thing for me would probably be making sure when dealing with a virtualized application that you understand the functionality of it from a user point of view. Because if you're able to understand it from a user point of view, you're able to then translate that to a bot. And then, like I said, with that print preview, for example, that type of functionality, the user itself, the process itself wasn't aware of it because he didn't need to be. But I was able, as a user, to go through and find that and then translate that into the bot to our benefit. So for me, the biggest tip would definitely, for me, be looking at the functionality of the application beyond what the current processor is doing and how that could be applied to your bot or automation.
Yeah, definitely. And one thing that we always take into account, and not just for virtualized environment, but for any RPA process that you're doing, the requirements. Sometimes it's a little bit annoying to gather all the requirements, but the more information you have about that process, the less complicated it's going to be doing the development. And one thing, never use delay because the thing is that it changes. Sometimes on your local machine, something is going to be appearing. Sometimes when you use the server, it's not going to look like it. So you have to take all those things into account when you're doing the developments. Once you work with that, you're going to have less problems while you're doing UAT or when the bot is in production. It's going to go backless.
Yeah. So there's the three. It would be hidden to make sure to understand the functionality of the application beyond what just the current processors are doing and how that could be applied to the bot. Second would be to make sure that you're rigorously getting all the requirements and really doing your due diligence in understanding what is required, because sometimes, and not sometimes, pretty much most times, processors they don't understand that the requirements they're doing, they're implicit after a certain point. So being able to really extract that and able to log it, so to speak, so your bot is able to use that is very important. And then lastly, is don't use delays. Use some type of logic that is waiting for either, if it's not a virtualized application, waiting for an element to exist. If it is, waiting for an image or an anchor, because delays really are just it's lazy programming pretty much.
Yeah.
So those would be
unless you need it.
For those cases. Yeah, for most cases, for these cases you do not. So those would be our three.
Fantastic. I think I spend a lot of time with senior project managers or business leaders, and everyone talks about all kind of the great stuff that RPA can do and how powerful it is. But I think this what you've been through just now is fantastic, because it really just on one specific area highlights that this is not easy. There's so many unpredictable, or maybe not unpredictable, certainly there's a huge number of challenges that any automation is going to face, and I think you've very clearly identified not only what the problems could be, but also how to solve them. And so I think I always go back to senior leaders and say, look, this in theory is easy, but the reality is that you need good guys on the ground that can understand the problems, understand the business process, as you touched on there, but also can be creative around what the solutions are. But just don't expect it to be straightforward and easy every single time.
Yeah, exactly. It never is. If it was straightforward, there would be they'd probably be able to do it themselves. Realistically, understanding the requirement for these rigorous requirements, a little bit of a tongue twister, that really is important in approaching any automation, because it'll never, at least in my experience, ever be straightforward. There will always be some type of branching validation that you have to take into account, to make your automation robust enough to be an actual solution that's worthwhile.
Well, fantastic. So, guys, I really appreciate both of you taking the time to do this, obviously prepare and present. But if anyone's got any questions at all, they can reach out to me and I'll give them your contact details, and we'll post this online as well. And again, just thank you very much. I appreciate it.
No, thank you for having us. Yeah.
Absolutely. It's a pleasure. We'll be we're unfortunately very busy on our current project. We're putting out a couple of more articles in the future. Hopefully, we can get one out by the end of this year on dealing with mainframe automation, just because we feel like that's another area that we've had quite a lot of experience in and quite a lot of use cases. And there's definitely some intricacies that are just, if not as in depth as surface automation, even more so. So we'll definitely be putting that out as well, hopefully as soon as possible. But definitely appreciate you having us, having us do this, and hopefully we'll be able to do one again in the future.
That'd be great. That'd be fantastic. Right, thank you very much, guys.
Absolutely. Have a great one. Thank you.
Take care. Bye.
Bye-bye.